So chapter 7 is parallel circuits, and parallel circuits are circuits that have more than one path. So remember, a series circuit had one path for electron flow, but a parallel circuit has more than one. So what I've done here is I built you a little series circuit, or parallel circuit, excuse me. Comes out of my power supply, and then black is negative, so this is the way the electrons flow out. Comes right here. And then when it gets here, it has the option. It can go through this bulb, back positive to my source. It could go out the green wire, go to this bulb, or it could go out to this bulb and then get back. So I've connected these back where they all can give me multiple paths. And the big thing you're going to hear me say a lot with parallel circuits is that electrons will always flow the path of least resistance. They're similar to you and I. They want to take the easy route. You and I, if we can go through a mountain, through a cave, or we can go up the mountain over top of it, or go around it, we're probably going to go right through it because it's the quickest, easiest way. Electrons are the same thing. So they'll pick the path of least resistance. So if you look at number 1, currently all 3 bulbs should be approximately the same size. They're all 1.5 volts. They're all going to vary a little bit because they're not like high quality bulbs. And our wires should all be the same, but they're all a little different lengths. So we get a little variance as we do this. So I've got this turned all the way down. I turn it on. And at 1.5 volts right here, all the bulbs are lit just a little bit. This one looks a little brighter, but these 2 are also lit. So voltage, anything under 1.5, they're not lighting. At 1.5, they just begin to light. And then as I turn this up, when I approach 3 volts, okay, I'm at about full brightness. So at 3.0 volts, I reach full brightness. And to you, this one may look a little brighter, and it is a little brighter. I don't know if it's just the bulb, but it is a little bit brighter than the other 2. The other 2 are very similar. Okay? So if I look at number 2, it tells me take one of those 1.5 volts bulbs out. And that's what I did. Uh-oh, look. The other 2 stayed on. So in a series circuit, if I took this one out, these 2 would also went out. But in a parallel circuit, since it has its own path, these 2 stay lit. That one goes out. And I'm going to get here a 3-volt bulb, and watch when I put this in here what's going to happen. And you know what happened here is I burnt this one out because I had a little too bright. So I'm going to turn my source off for a second. 3 volts with 2 bulbs was too much, so I fried it. So I get a new one. And if we did our calculations with Ohm's law, we're going to know that that's way too much for it. So now I'm going to turn this back a little bit, turn it on. I want to start slow. Come in here. And this is not a 3-volt bulb, but it's a 3.5 volt bulb. So I need to set my power here, at about 3.5 volts to make that light. And now I'm burning this one out all the time. Okay, so did another one, so I'm going to shut it off. If you did this in class, I'd be like, come on, pay attention. So I'm going to get it set here, right? Back it off a little bit, turn it back on, and we're good. Starts to light. So this bulb here won't light until I approach about 3 volts. Now I got to back it off. I'm going to burn these off. So which bulb reached full brightness first? It would have been the 1.5 volt bulbs. What is the full brightness? At 3 volts, these 2 reached maximum brightness. If I go any higher, like you saw, I start to burn out those bulbs. And what conclusion can you make about the voltage based on results? I think you can see that. This path is a higher load, has more resistance, so less electrons go here, so this is barely lit. Like if you can just barely see it, I can right here. You may not be able to tell it through the camera lens. If I go any higher, so that this gets brighter, then these are going to burn out, and I don't want to do that. What I could do, though, is I could remove these. And I'll turn this up now. Now you see that one lights because in a parallel circuit it's got its own path. So I can get that up to about 3.5 volts before I start to have issues. And I'm just turning this down and backing it off. I already removed the middle bulb, and you saw that the other two stayed on because it's got its own path, and all of that works. And one of the things I also want to show you when I have camera here set up is this little device right here called a multimeter. Multimeter because it measures multiple things. So I can measure DC voltage, AC voltage. I can measure resistance of a piece of material. I can actually measure temperature with this in Fahrenheit. I can measure amps, and I can also use it as a continuity tester. So when I turn it to the continuity tester, it'll make a noise if I have a complete path. So I'll just touch these. So if I wanted to check this wire here, and I didn't know if this wire was good, I could come in here and take it off. So that's a continuity tester. It checks to make sure things are functioning and working properly. And this is a multimeter. Lots of these, we've got like a dozen of them that you could use to test different things, voltage. We use them in auto labs, we use them in electronics, and we use them all the time.